Good afternoon, everybody. Hi, we're delighted to welcome you for this last event in our series of professional developments. For those who don't know me, my name is Florian Carl. I'm the manager of the Yale Quantum Institute, and I'll be moderating this panel. So we are delighted to continue this series that is jointly organized by the Engineering Workforce Development of the Center for Quantum Network in Arizona. And this is our last panel, the fifth one, and we will focus today on job in the industry system. So we wanted to offer this series because there's a lot of question about what kind of classes should I take to join the workforce and work in quantum physics or quantum science? Like, should I be more of a physicist, more of an engineer, or more of a quantum scientist? And we recognize that there's a lot of people needed from very different backgrounds to be able to achieve all the technical details that we need to have a robust quantum science, quantum information, and build quantum systems. And it could be very overwhelming to consider all these options for a career in quantum information. So today we will hear from recent young professional who graduated and joined industry, as well as career development professional. And so we'll be here to answer all of your questions. Before we start, I would like to introduce Matthews, who's the student liaison counsel for the Center for Quantum Network, and he might say a few words about the work that he does for the CQN.
Hello, everyone. Well, my name is Matthews. It's a pleasure to be here with you today. And well, CQN is a research center funded by NSF with the goal to build a quantum network. And I currently work with the development of algorithms to work on the software part of the quantum network. And essentially, we have working groups in many different aspects of the field, from really physical research to actually build the quantum hardware that you actually need for a quantum network, to the spectrum of the impacts that a quantum network would bring to society.
Thank you very much for this overview. And so if you want to learn more about them, visit CQN, the CQN website in Arizona. So let's jump right in and let's introduce our participants. So feel free to turn on your webcam. And while you do so, I would like to give you a little bit of advice and design for the series. So we're gonna start with the introduction of the panelists, and then you can use all the attendees can use the Q&A feature at the bottom of your screen, where you will see you can ask all your questions. So you will go through during the hour. We'll go through all of the questions and try to answer all of them. So let's start by introducing our panelists. So let's start with Teresa, for example, if you don't mind. So feel free to remove the webcam, and so go ahead.
Hello, I'm Teresa Brecht. I'm a researcher doing quantum device physics at HRL Laboratories in Malibu, California. This isn't the real ocean, it's just a backdrop on my wall, but the real ocean is just right out there, and it's nice and warm today. Here I work on quantum dot qubits, doing experiments and measurements, and also developing software for those. And I've been doing that at HRL for almost 5 years. My background before joining HRL was in superconducting qubits. I graduated from Yale in 2017, and my PhD advisor was Rob Scholkopf there. So that's it.
Thank you very much. Zlatko, do you want to go next?
Yeah, sure. It'd be my pleasure. And hi, everybody tuning in. I'm actually in California right now, too, though normally based in New York City. And I had it's actually really great to be back at Yale, at least virtually. I overlap with Teresa. We started our PhDs, I think, at the same time. So I was in the applied physics department with Michel Devoret from 2018 to 2011. And after working sort of very hard in the last few years of my PhD to, finish this last project I was doing, catching and reversing a quantum jump, I think I applied to something like 10 or 15 postdoc positions and basically everywhere in industry. So I wish we had these panels earlier, and it's so awesome. And at the time it was a different landscape. So I'm really sort of thrilled that Florian and the YQI and you know the new institute here in Central are organizing these, because this is exactly what I would have loved to have even more of. And then I moved on to, you can hear the story later, and moved on to a research path at IBM Quantum Computing. I've since had a little more unorthodox path. I've now founded and am the technical lead of our quantum device design and analysis project called Qiskit Metal, which makes it possible for basically the first time for anyone to design their own quantum devices from their computer and really speed up and accelerate the process and the innovation. I also lead and host IBM Qiskit's Quantum Information Seminar Series, and I'm a lecturer at the Global Summer School through Qiskit. And recently, sort of thankful to share that my roles kind of expanded to also found a new team that's going after high risk, high reward research. And that's in a management position as well, while still staying very focused on the research aspects of it. So a bit unusual and a bit more hybrid in that sense. So hopefully I will have a few interesting tips and 2-cent messages to share.
Thank you very much, Zlatko. And then our last panelist, Melanie, if you want to turn on your webcam and introduce yourself.
Sure. Thank you so much, Florian. My name is Melanie Cinch, and I serve as the Interim Assistant Dean for Academic Affairs and the Director of the Career Center at the University of St. Joseph, which is in the center of Connecticut. So I'm actually in the Northeast right now. Right now, I am also serving as a consultant to Yale University, and I'm working with all of their PhDs and postdocs with all disciplines, primarily in the sciences. But I have been a career counselor for just over 20 years now. My specialization is working with PhDs and postdocs in the sciences. I actually wrote a book on how to find a job for PhDs in any branch of science called Next Gen PhD. And so if any of you are interested or want to connect, please feel free to get in touch with me if you have questions following today's panel. I love connecting with scientists at any level. If there are undergraduates on the call or graduate students or postdocs, I'm also happy to connect with Zlatko and Teresa and Florian and Matthias, because you know, I love learning more about science. So I'm not a quantum scientist on the panel, but I'm interested in hearing about the paths of Zlatko and Teresa. So thank you for having me, Florian.
Thank you. That's my pleasure. So let's jump right in on the questions. So I think that's going to be the first question I have, is like what it's like to work in industry, because for like since like people asking that question, I've been at school for the longest time. You go to high school, college, grad school maybe, and what is it like? What's the difference? Because all of you were in labs, in students, and so who wants to start with this very general question? Like, what's the main difference? What you should look for, and all of that. Who wants to jump first?
All right, I can maybe lead it off if you'd like, and then Teresa, you can jump in. I think maybe the first thing to just acknowledge is that it's not monolithic, whether it's in academia or in industry. And I was thinking about this a little bit because, you know, the experience I think I had starting at Yale in my graduate degree in 2010, 2011 is very different in a sense from the experience a student starting today would have. The whole landscape of quantum has changed a lot. And so I think maybe that's the caveat to begin with, is that it's easy to apply the blanket statement of industry, but really there's so many different flavors. And that's part of what your experience is. It feels like a bigger world in some sense. And it's a lot more dynamic. Part of what you'll definitely see in a lot of industry, especially as you move into more like technology industry and the kind of industry that quantum is headed into, is that it's a little closer to like the machine learning tech industry, where things happen in like 2-year cycles, 3-year cycles. So the pace is definitely one major change that you have in terms of sort of the schedules and pace. And also you work in much larger groups and teams typically. It's definitely more oriented on like potentially creating stuff. It's a little less significance driven than, publish this paper or so forth. I think at the same time, though, it really depends, because there are many different cultures. You've had a startup panel, that's going to have a different kind of slant on it versus a large organization like IBM, which is huge and is very global and worldwide. So you're going to work with people that come from tons of different backgrounds. So this is one of the maybe biggest differences. I'm not constantly surrounded by like-minded people who had the exact same training for the last 20 years as me in physics. I'm working with software developers, product designers, physicists, engineers, material scientists who have different trainings, whose value system is a bit different than mine. We're not all after the same thing. And so I think kind of readjusting my own values in this environment is one thing that I think inadvertently will happen. And that's also true in academia too. I think as you go to the next stage, those will have to update. But it's certainly a lot of sort of interaction, a lot more team focused in a sense. And maybe I'll pass the ball up to Teresa, because I could probably keep going here for another 10 minutes about this, but I'll let Teresa pitch in.
Yeah, with like riffing off the first thing that you said about it not being a monolithic industry versus academia, part of that is that there are many partnerships and programs that foster collaboration between academic groups and industry. And that can take many forms of either sharing technology or doing like postdoc visiting at a research lab in the industry part. So there's a lot of activity going on there, and a lot of those sorts of collaborations are now being encouraged by the government in new programs. One thing that I really appreciate about working in industry over academic labs that I have been in is that you get to participate in really efficient technological development in a larger team where there's career experts in their specialized roles that can be really relied upon to perform their function at the highest level. Like, we have a hardware team that has been doing hardware development for decades and gone through many technological innovations over that time, and they know how to like carry things forward. We have a fabrication team that is also very high in expertise. We have a software team, and they're all really good. And it's not like that in academia, where like by design, there's a lot of education going on and there's a constant export of talent. So that's where you go and like learn everything. And there are many, that's where all the smartest people in the world are, right? Is at the universities. But then once a person becomes an expert in something, they leave or go and learn something else. And I guess what I appreciate about the industrial environment is that like experts stay doing what they're expert at. And then by constructing the teams efficiently, we're able to work together to like build something that's much bigger than you can generally achieve in a research group.
Yeah, that's a really good point. I think we've saw that in the different panels that we had over the last year, talking about like if you're joining an academic group as a PI, or if you're joining a startup or industry, you have really different roles because the goals are not the same. I think academia has more of an educational purpose to train people. Startups will try to disrupt and find new ways, and industry has more of a product and like productivity in mind to have something. And so I think that's something you want to consider also for your researching careers. Like what's the end goal? What would you like to do in your life? Do you want to teach students? Do you want to create stuff? Do you want to create a product that could be used widely by the general population by a system? And so that's something to also keep in mind. And so since you have so many options on that, can you talk a little bit about what your day-to-day like is in industry for people who have no idea, like, because I think the monolithic idea comes from the fact that we have one word to describe all of that, but there's so many different jobs. And so what do you do? Like if you have a typical jobs?
Yeah, I can maybe jump in here and build off of what you and Teresa said. Um, and also, like teaching and all these different things. Like initially, I think before joining this industry, sort of research side of it, I thought there was less of that, but actually we have a giant team focused on education. And one thing I never anticipated is I've taught at 2 summer schools now on like introduction to quantum hardware and introduction to quantum noise. First one had like 4,000 something students. The second one had like 5,000 plus students, global and worldwide. So I think one thing I found is that there's just a pretty big world, and usually if you really want to be happy, you kind of have to align your interests with the larger interests. And oftentimes you can we're all, if you're doing a degree in something like quantum, you're usually a pretty smart, resourceful person, so you can find kind of those potentials. So that's why a typical day, for me at least, has evolved a lot. Initially I've had days where it was just very focused on work. Nowadays it's a lot of more mission building and team building as well, kind of trying to scale as well. I think the interpersonal becomes a lot more of your time as well. I think typically in industry, because you're really working in teams, and as you try to take your mission to greater things, it becomes more of a mission to that. I've had sort of sprints where it's been just software development, and sprints where it's been a lot of like reading papers or physics. So at least in my case, it's been quite colorful, and it keeps evolving and shifting. And so it's been a lot more dynamic in that sense. So I'm not sure if that's helpful, but hopefully it helps paint a picture.
I mean, everything is very helpful, because what we're trying to do is like trying to see like how people who have similar background experience their new role in industry. And so I think it's very helpful for people to know like exactly what it is, because somebody who doesn't like to teach and end up in your position might be disappointed that he was like, they were finding something slightly different. So yeah, it's very nice to have.
Yeah, and I think oh, go on.
Oh no, keep going. Yeah, sure. Yeah.
Yeah. I guess that's sort of the thought I had here. And one piece of advice I kind of heard, I think when I was interviewing and applying was, there's no perfect position for you. Ideally you define your own position, and that's the only time you're really going to have that perfect position. And I've had the chance to kind of keep reshaping it. So I think maybe that's one thing to keep in mind, is like, you have an agency in this. It's not like you have to fit in a fixed bucket and fit the mold. Like, you have agency, you have flexibility. So I'll leave it at that.
And that's something that we'll talk about in a few moments later. We're going to let Tara talk about her experience in HL, and then we'll talk about how you can craft your job to really match what your interests are.
Yeah, I think that's a really excellent point that you're emphasizing, Zlatko, that you have agency to craft your own experience. That's especially true after you've sort of like done your service of a year maybe at the company to like show that you're smart and can work with people. And then like you can kind of move into what you figure out is your ideal role as you figure that out, or if you want to try out new things within the same company. Thankfully, like you said, Zlatko, I've been able to keep my experience kind of dynamic and try out some different things, and day to day is not always the same. When I first started at the company, I was mostly doing experimental measurements, measuring the quantum devices. So I would go in and do electrical tests on the devices, sit down at a dilution refrigerator, or remote into a computer where I was accessing a device that's cooled down in a refrigerator, and do electrical test on it. One difference between my experience here and graduate school is that we have a lot more meetings because we have these specialized teams. We spend more time getting together to directly provide feedback between the different teams. So as part of the measurement team, I was reporting the results of measurements back to a fabrication team, and also interfacing a lot with a theory and modeling team so that we could validate their models. Yeah. So that's been fun. And as my experience has evolved, I'm now more interested in software.
I think that's the interesting thing about industry is that you can like sort of find, especially if you join big groups or big companies, you have different nodes, and then you can sort of pick and evolve in the same company in a way that will not be necessarily possible in academia, I think, because you cannot change your group goals like every now and then. And so I think now we can jump into more of the nitty-gritty of like, how did you land that job, and like how do you prepare for the job search? Why were you interested in? And then also, what are the advice that you can give to people who are seeking job in industry? How can they prepare to work on that? Anybody want to start?
Great. I can lead that off if you want, because I started on the other side and now I'm more on the hiring side. Yeah, I have 2 job postings up actually. So one is on Qiskit Metal, like more software developer, physicist focused. The other one is really more researcher level focused. And those are 2 different roles. So for the different roles that you're applying for, you're going to have different processes. Exactly. And I think the first thing you can always start with to prepare is just yourself and your own background and material. Usually if you're in science or a researcher, you will get asked to tell people about your research, your work. And so you want to make sure that, that's fresh in your mind, you're competent about it. Oftentimes you give a talk or a presentation. So I had to give a talk and a presentation. I had probably given that talk and presentation like 18, 19 times before giving it in many other, rounds of interviews. Sort of, I went maybe extra. I don't think you need to do it 20 times, but you can really prepare that and have sort of a sense of questions ready. And I think the other thing, folks look for a lot isn't just a technical competence. That's kind of like, let's get you in the door, but that's the bar, right? It's also, is this a person that we can get along with? Is this a person that seems like they actually want this? Are they applying for the right reasons? Are they motivated? Like, are they eager about this? Because you can have the right skills, but if you don't have the affinity for the mission, you're going to end up leaving, or you're going to just not enjoy the job or not do a great job. So affinity is another key thing, like demonstrating that in some way. And then as you get to more like software or more of the different sort of more desirable positions, especially like in the new climate, you're often going to have a coding interview, a behavioral interview, and a technical interview. And then if you pass those, you talk to like more team members, more for like culture fit, and can we get along, because we all need to play together. And so the coding interview, there's like many books in coding interviews. For if you're going for a software position, those really matter, right? Like you want to know whatever language it is, Python. You might, there's like thousands of resources online for coding interviews that will walk you through the basics. If you're a physicist, sometimes those coding interviews are more like, okay, can you be proficient enough to do your job? But that's not weighed as heavily. You might have a physicist interview where you get asked, what's an Ising model? What are spin interactions? How do you measure T1 or a T2? Depending on your, if you go into a measurement team, you might want to. So oftentimes you want to understand, because the job postings tend to be quite vague. You want to understand from the hiring manager up ahead, like what's really the general focus of this role. And then, sometimes you have behavioral interviews, so you can kind of look those up. Depends on, different companies do it differently. There's no place that has the exact same process. But really the idea there is just to make sure that, you sort of have a good mindset, right? And maybe I'll lead it off to Teresa to add on more here.
Sure. I like what you said. And I would add to that, like, don't try to squeeze yourself into a box that you think the ideal candidate for a given position is describing. Oftentimes the job requisitions are written in a way that I think you said opaque.co. Ours are like that too. I'm not sure why. They pass through some kind of HR filter before they go out there. Anyway, like, generally what places are more looking for is, what kind of a scientist are you? do you have the affinity for doing something that is matching with the mission of the organization, and are you a good cultural fit? So yeah, I guess don't try to squeeze yourself into a box, because you don't know what that box looks like, and the company wants to hire a good scientist. And once you're at the company, you generally will have some freedom to be you at your best. Right. I guess one more thing about giving a research presentation. It's like Zlatko described, when you go to do a presentation, it's just like doing an interview talk for a postdoc or professorship candidacy. Usually you talk about some prior research project, common to basically recycle your thesis defense presentation, right? But my piece of advice is that you need to communicate something technical and prove that you could do that, but you also have the opportunity to share more about yourself and what kind of a scientist are you? What kind of challenges have you encountered and had to overcome? How do you work with and appreciate other people? If you can add little anecdotes to that end in there, more than just conveying physics information, we really look for that.
Yeah, and I can maybe add to that also, like, if, because people tell me, oh, people look for culture fit. I was like, what does that even mean? Like, what are they actually, talking about? I think a lot of times that's the kind of thing where it's not like you have to exceed. It's not like you need an A+, you just need a pass. Like, is this somebody that, I could see myself getting along with? It's the kind of thing that's more making sure there's no red flags. Like this isn't just gonna, derail the mission. And so, I think just don't overstress about that as well. And then I think, like Teresa said, yeah, make sure that, you're kind of genuine yourself. And one thing that I do notice folks, sometimes in interview processes, what oftentimes will happen is they'll get like stressed or freaked out that they don't know the answer to something, or they can't quite remember it. And the point of these interviews isn't for you to get it right. Most of the companies, they're just testing for the boundaries of your knowledge. And just getting a sense. So actually, as the hiring managers or the interviewers' job oftentimes is to just keep asking you questions until you can't answer anymore. They just want to see where that boundary is. And if part of it is shallow, that's okay, because you've probably got another part that's deep. And you can help steer the conversation too. It's not always clear to the hiring person exactly who they're dealing with. They just had 3 minutes right before this talk between the other talk to like look at your CV. So you can help guide them as well. Like, these are things I'm strong at. These are things I love to do. And the two of you can kind of work together on that. And yeah, have energy, have excitement. Don't let that stress kind of, really make you tense.
And Melanie, you're our expert on that field. Can you give us some advice and pointer on like what to do? Because we had excellent advice from Teresa and Zlatko on practice. So like, how can students right now who are looking for jobs can put all the chance on their side to land a position?
So I think that's an excellent question, Florian. And I have to say, everyone on the call today is taking a great first step, right? They are hearing from people who are in industry, and they're hearing about what people in industry are looking for. So Zlatko has, some postings coming open, and, he'll be hiring soon. And so it's good to hear from hiring managers. It's good to hear from Teresa about her experience on the job and what her employer looks for and does. And so you can go through this exercise on your own, whether you're an undergraduate or graduate student, postdoc, or someone who's on the job market now, through networking. And I think networking is critical to anyone who's interested in this field, because the more you can connect with scientists who are doing the work now, the more you'll hear about how to prepare. How do you prepare to give a presentation? How do you prepare for a behavioral interview? What does that even mean? What kinds of questions might you hear? And Teresa mentioned cultural fit. What does that mean? And how will you ever know whether you would match a particular company's culture. That is all through talking with people who are actively in the field now, right? So you can do that through LinkedIn, you can do that through scientific societies, professional associations, you can do that in many different ways. I know that Yale actually has a very robust alumni database. And so you can get in touch with people who are working in quantum science now through possibly your institution's alumni office or the career center. So there are many different ways that you can start to get into the field, make contacts in the field, even before applying for jobs. You can be online and you can be looking at job postings and you can be applying. Oh, that's great, Zlatko. That's excellent. So Zlatko mentioned on the chat that he's on the Yale alumni database. So it's important, and someone on the call has already connected with me on LinkedIn. If you connect with any of us, then you'll be connected or be able to see all of our connections. So it's important for you to start building out your web of contacts because that will help you once you do see a posting that is interesting to you in your field. You can start to apply online. There's nothing wrong with applying online first. There's no harm in it. It's free. But the chances that you'll be called back are so much more likely if you have any connection at all with any person, any scientist, anyone who's connected to that organization. So networking is the key, I think.
Thank you. And then, you were mentioning all the resources. So we know fairly well the career resources at St. Joseph, at Yale, and at the University of Arizona because we're working with them. But I'm sure for anybody who is affiliated with any university or any school, you should be able to find similar resources in your center. We have a couple of questions on the chat from the audience. So we were talking about how to prepare for interview, but also what are the skills that are currently hard to find when people are trying to hire new quantum employees? What are the skills that are value for employers? So I think this is a more I think it would depend on the type of company, but do you have a sense of is there a gap in the market and then people should go into certain avenue or consider a certain path because that's something that you see in your industry? It was oh, we wish we could have that type of skills. What could be something that current students should look into?
Teresa, do you want to swap around and you go first this time? I can go first too if you want.
Well, I don't have a sense of the whole quantum workforce market.
So do you want to talk, for example, I'm going to put in the presentation, I see that on your website, on the quantum website section of HLR, you have a lot of job posting. Currently, there's 29 posts. And so when you see this thing, it's mostly people with strong background in science. So I think one of the things you need to do is quantum is pretty rough. It's a pretty difficult topic, and so having strong solid knowledge in physics, STEM, or engineering is something that will be helpful and will also help you transition to other jobs. But yeah, if Zlatko, if you have more,
I can jump in. I mean, there's actually there's an entire field of people working on identifying the gaps in the workforce and workforce development. Workforce development in of itself is a whole thing. You can, it's a whole big part of IBM and big industry. And so there was a LPS collaboratory workshop. I gave a little speech, and Will Oliver and all these other people were there too, from industry and government and all the sectors, right? And they're identifying the gaps because there's so many different positions. So I think they're going to have an official big report, and it's going to have a very well digested version. I think some obvious things are just quantum. I mean, just quantum skills in general. There's 50 posts between HRO and IBM now. That's a lot of posts, right? I mean, how many PhD students get produced per lab per year? Not a lot, right? So just quantum basic 101, understanding quantum physics, quantum algorithms to some degree already is just a huge gap. So that's changing. I mean, even at the master's level, especially even at the master's level and the undergrad level, that's like those jobs didn't exist before, but now there's a lot of demand for those jobs. Like Teresa said, not every single person needs a PhD to do their job. The PhD gives you a lot of breadth and depth, but this is great to add on. I think the other skill that, I think would help a lot is really just software. I mean, especially in quantum, software is a huge part of everything we do. The way we run experiments, the way you go into the lab, almost everything is software controlled. Anything higher level, anytime you want to work with, whether it's client or researchers, or you want to do anything, it's usually through software. And that was a skill that like half of our group was really into, and the other half was totally against, basically, at the time, in my degree. So having better sort of developer software skills, even if that's not your primary role, is just such an essential tool. And it really, I see it in a lot of candidates. It's not to the level that it would really benefit them. I think another one is, I think especially more, presentation skills are always very important as well, because you end up having to present a lot. But I think just within quantum, just understanding quantum and different, understanding a little bit about quantum computing, quantum basics, fundamentals, some quantum algorithms at the basic level. This is all super helpful.
I actually have a question. You've all been talking about software, and so we have a question from the chat. What is the difference between applying to be a software engineer in a big tech company, which I think is probably like thinking about how to develop Twitter, Facebook, this kind of software needs, and the difference between being an actual software for quantum systems? Is there a difference, and how do you get this? Because you can start coding on Python for your mini app or something like this, but how do you start coding on a quantum system? How do you train yourself for that?
I can go first, Teresa, whichever.
I guess something comes to my mind, and that's that there's of course a wide variety of software tasks associated with the field of quantum information, and some of those are more theoretical, but on the experimental side, the stress on the software is more related to the interface between the software and the hardware, because our hardware of the quantum system is in many implementations inaccessible by being at the level of dilution refrigerator. So doing the quantum software is really doing a special kind of classical software to control whatever control electronics there are, whether it's control electronics at the top of a fridge or advanced control electronics. Some companies are doing cryogenic controllers, and software needs to be written to control this very, very specialized hardware. And that is a unique skill that I wouldn't say is shared with the app development and stuff. It's very much a need.
Awesome. Yeah, and I would add to that, right? So there's software that's lower down the stack, as you might say, closer to the hardware. Usually that requires a lot more domain knowledge, a lot more expertise about, usually need to have worked in a lab, not necessarily, but usually, to actually understand the qubits, what's the Rabi rotation, how does it work, what's pulse shaping, pulses. So if you want kind of a more, what I'll colloquially call hardcore quantum software developer position, you really need to be pretty good at that. Sometimes, there's a lot of work on compilers. So in that case, you might need compiler knowledge background as well, or you can pick it up on the job. I have a good friend who's absolutely excellent at it. He just picked it up. But I think overall, there's definitely more of an emphasis on quantum. It's probably a little different in that I think, if you're going for a traditional software role, you're probably going to get a lot more questions about software architecture and software design. You're going to have a software design principle part of your coding interview, I don't know, different model view controller framework, or you might get asked questions like that. Whereas here, I think it's more like a mix between the quantum flavor and the like, do you have the right abstractions? Can you build abstractions correctly in place for that? And do you just have the operating skills? And can you work in an for part of industry, can you work in an open source environment, or have you done contributions to an open source repo? Do you understand the open source ecosystem? That's part of, that's one big part of industry, because many of these industries, IBM in particular, is very open source based, and that has a slightly different flavor. And, obviously project management and so forth, like GitHub and all that as well.
Thank you. We have another question from the chat. Are there any opportunity available for undergrads to have hands-on experience on quantum hardware? And like, is there internship possible? And like, where do you find? And I think that could also be a question for Melanie. Like, where do you find the resources? And like, is there like a job posting board somewhere that has all these opportunities? And what could be? I know there's a ton these days. There's a ton of hackathon happening all over the world. And so while it's not hands-on on hardware, you will still code onto actual hardware through the cloud system. But do you have any mention of like what students can do? And is there like clubs or stuff in the or like opportunities for internship in companies? And where do you find this?
So I'm so glad you mentioned that, Florian, hackathons, because the ability to code and having some concrete evidence for any employer, of your skills is so powerful. It's so meaningful. So I think that the more that students can engage in that activity, the better. In terms of postings for internships, I would think carefully about where you'd like to be geographically, and then look at local quantum employers and people who might have internships available, and go to their websites directly. I'm not as big a fan of big, broad job boards as I am, for particular places like IBM or HRL having their own posts. So that's more, I would be more targeted in terms of where you'd like to be geographically, and then target some quantum employers.
Yeah, and I can probably also add to that, because quantum hardware design is kind of a lot of my world. I would say look at what projects are out there and try to get involved, probably through open source, and that will often lead you to hackathons or Slack channels where you're going to meet and discuss, and people will post things. So for instance, we have several internships for Qiskit Metal, which is software for quantum hardware design. So you get to work, with that. We designed a 5-qubit device that's going to the University of Tokyo with Qiskit Metal. Some folks from Chalmers are using it as well. There's a summer school, actually, I think it's Quantum BC in Canada and CMC Microsystems. They organized a summer school with Qiskit Metal where you get to design your quantum hardware, then actually gets fabricated, and then you measure it. So these opportunities actually exist. Some of them are more regional, some of them are more international. There's like global summer schools on that. But if you kind of like contribute or hang out, first of all, if you hang out in like a community like that, like a Slack channel, that's great. But if you're active and you contribute to a code base or something like that, like people who are working on that will notice you immediately. They're going to know your name. And if you ask internships, like people will reach out and actively help you. So I think that's always a great way. Like Melanie said, don't just go to like jobs.com and type in this, because you're going to spend a lot of effort and your result is going to be a lot harder that way.
And all these advice are valid for people who are international. So we are all based in the US, but there's, I think, since the pandemic, a lot of companies, a lot of universities have moved towards online platforms. And so while the hackathon that you could take part was locally, like people would have to be in the same room, now they're like available to any countries in the world. Like it's going to be a challenge for the time zone sometimes, but I think some big companies are hosting different hackathon for different parts of the world. And one thing that you get out of this is that you also build your network. And so people who, the reason why these big companies and university are hosting this hackathon is really to get talent. And so finding a job is not really just a hunt for you as a candidate. You really, like, the company needs to fill these places. It's a need to work. And so it's not really, you're not fighting against industry to get your job. It's mostly a collaboration. And so if you can work with your network and with the people who are hosting the hackathon, who are judging, who see that you've proved that you could do like some amazing coding or some amazing way of like processing a different signal in a different way, that's something that they might keep in mind, and then they might post, or they might follow up and send you a job posting, say like, hey, there's something that you might be interested in. So yeah, I think the geography, while it's challenging, is not really a big barrier. Like, there's a shortage of quantum worker, and so no matter where you are in the world, I think if you have the talent, we'll find a way to bring you to where you need to be. So that's also something. We had a lot of questions in the chat about international students going on this thing. We have a few more questions. One is about, so that's an interesting question because it goes between the few panels that we had in the past. Do you know of any former coworker who have branched out from industry to startups? And so what is is there a lot of lateral motion between these two different systems? Like, can you go from like industry to startups and then come back? And do you have any experience with that? Like, have you seen any people who've done that?
Yes, I've seen people go both directions. I think it's just part of this fairly small but growing world of quantum in industry. I have friends that have gone both directions.
All right, cool. So that was a good thing. We are almost at the end of the panel. So what I propose is that yeah, well, I'll give you the one in a second, Matthew. So like, we're gonna talk about one last topic, like what would be your advice, like general advice and final remarks for this thing. But before we do that, Matthew, I see that you have your hand raised. Feel free to answer.
Yeah, maybe. So I guess my question is from the perspective of a graduate student, a second-year graduate student, who is actually considering to go for academia. And maybe it's a more personal question. So what was the point that made you decide to go to industry? Because at some point, I guess every graduate student needs to make that decision, right? So how did it happen for you?
I can take this one first. So for me, it was like way after I got my job offer. Actually, I only applied to industry as a exploratory side option. I was primarily looking at doing postdocs and just more traditional path if you want. So it was a bit of a surprise actually finding myself giving a career panel on joining the workforce in industry. First of all, I think my advice would be, from what I have seen, there's about like 2% correlation between what a second-year grad student and what a sixth-year grad student coming out of their PhD is thinking in terms of academia versus industry. So honestly, I just wouldn't worry about that very much, because almost every single person I talked to, they were like, oh, I'm 100% going to industry. I'm 100% going to academia, or academia sucks. Academia is awesome. Like, by the time you're in your fourth, sixth year, you're a totally different person. Like, that stuff is like, so whatever you're thinking now, just forget it. It's cool. It's great you're thinking about it. I'm appreciative of that. But honestly, just focus right now on developing yourself to the best you can be in this environment. Because if you're looking over there, but you're having to move in this direction, you're going to trip up, and industry's not going to go as well as you want, and academia isn't. I would say just develop yourself. I mean, at the same time, go to career panels, go to conferences, build that network that Melanie mentioned, talk to people on both sides and get a good environment. But you do not have to make the decision right now. You do not have to choose right now. And whatever you choose right now, it's, your ultimate destiny will work out either way. So that would be my first advice. I think, how did I choose? Like I said, I ended up choosing very late in the process. And I decided that, it's a very unique time in quantum. That's the other thing you cannot predict. I mean, when I was in my second year of the PhD, there was no quantum industry. I mean, maybe IBM was the only place, or maybe there was like 2 places or 3 places in the world that had quantum teams in industry. It didn't even exist. Even in 2015, it was like, pretty late in my PhD. I didn't really think industry was a thing in quantum. And so the landscape will change and you have to adjust with that blueprint as well. And so I think at that time, it seemed like, this is a once in a, blue moon kind of potential opportunity with what's happening with quantum. If there's ever a time to, be more adventurous and do an experiment with my own career and my own life and see how that goes and where that takes me, this is the time. And I decided to go on a bold faith and leap and, explore this other pursuit, knowing that, it may be a little more difficult to sort of transition back to academia proper if I wanted to, but that's always an option. These decisions aren't final. Because we have seen people going from industry to startup, industry to academia, academia to startup, academia, it's like all these pathways are possible.
And one thing that I want to add also is that there's a ton of opportunities you're not even aware of. And so if you really focus on one aspect of things, saying like, oh, I want to work on that field, you might miss something that's very interesting. Like, for example, I worked in higher ed education, like I'm doing more program development for quantum students and researchers. And it's something that I was not really, like I was following the path of like, I have a PhD, I want to become a faculty member. And then one day there was this opportunity. I was like, oh, that sounds like an actual job that I would like. And so I think that's also something to keep in mind, is that this panel are divided in like section because we need to find a way to put them in boxes. But there's also, it's more like a continuum. And I'm going to make this corny joke about quantum system. It's not on and off, but it's all of the above. Everything is like mixed together, and you have all these opportunities that can really like come your way. And so yes, so thank you so much for taking the time of being on that panel. Maybe we can do one last round, and then if you have last piece of advice for all of our attendees, that will be wonderful. And in the same times, I will put on the slides. If I can find my slide again, here we go. On the slides, the job posting of your two companies, so people can have a look. So maybe let's start with you, Teresa, if you want to have a last word. That could also be like, good luck.
Sure. Industry jobs in quantum fields are definitely here. I think they're a pretty attractive, great option. For me, my appetite was whet for doing industrial R&D probably before I started graduate school, because I worked in a R&D lab that was actually in chemistry. So I kind of knew that I wanted to work in that environment before starting my PhD. Yeah, and now that I've been doing so at a single company for 5 years and seen remarkable progress in our technology during my time here, I find that exciting. If you're interested in learning more about quantum dot physics, I encourage you to find our papers and videos, or we have some videos of our conference presentations on our website. And we're hiring people from a variety of backgrounds. Check out our website.
Thank you very much. So yeah, you have the slide on your screen. Zlatko, do you want to say a few more words?
Yeah, awesome. I mean, Teresa said it perfectly. Really awesome. So what other words do I have? I think one, don't stress out, honestly. You're in like a golden age. Maybe pause and just take a moment of gratitude for, how awesome of a place you are. I mean, if you're in this quantum seminar, like you are in the golden age. You're really having a great time. And there's so many opportunities and options. And like Florian and Teresa said, like, I've been in industry for a few years now, and I keep learning about new roles that I didn't even know existed, even within my own company. There's just so many different varieties and flavors of opportunities. And I think with that, I'll re-echo what I said, is like, yeah, you can start here, but at the end of the day, I think your greatest potential for joy and happiness will be if you can help define your own role down the line within that as well, as much as possible. And yeah, just, reach out to folks like Teresa and me or your friends and just hear their stories. That will really give you a great map of the landscape. And I'm sure you'll do great.
Thank you, Zlatko. Melanie, do you have a few last word of advice for our attendees?
Sure. Just follow your passion. You know, I think everyone has talked about that on the call today. And Florian, I'm so glad that you shared more information about your job, because there are so many opportunities out there for students interested in being around quantum, talking about it, writing about it, studying it, contributing to the field. You know, there are so many opportunities right now. It's like Zlatko said, this is a golden age. Such an exciting time to be in quantum. So I think I would really think about what you like to do most and really pursue that. So thank you so much for having me.
Of course, my pleasure. And then while we conclude, this is the list of all the panels that we had in the past. So we tried to cover everything from how to prepare and choose courses for college, how to prepare for grad school, how to prepare for faculty, and we also had one for startups. And so all of these videos will be available on replay on the Yale YouTube channels. So thank you very much, and I'm putting the link in the chat also if you want to know. Thank you very much for your time. Thank you all for sharing your experiences and helping us understand what it's like to work in industry. And thank you all for attending these seminars. I hope you have a wonderful evening and a great weekend. Thank you all.